Hello everyone, this is Sumant. Now we will talk about some evaluation methods for the ML models and a brief introduction to Amazon SageMaker. Okay, the first one, the confusion matrix. It is one of the evaluation methods as we said before. Okay, why do we require it? Because sometimes accuracy doesn't tell the whole story of how the ML model is performing. So we will discuss how it is helpful and dive into it in the next slide. This is how a confusion matrix looks for a binary classification problem. Okay, the confusion matrix, it is a table often used to describe the performance of a classification model on a set of test data for which the true values are known. Let us take an example of a binary classification problem of classifying a person whether they have a cancer or not. Let us assume we have 165 patients. Each row in the confusion matrix represents an actual class. See, this is the actual class, and each column in the confusion matrix represents the predicted class. This is the predicted class and this is the predicted class. And you can see there is something TN, FP, FN and TP. Let's see what they are. TN stands for true negative. It represents the values which are predicted to be false and are actually false. Whereas when it comes to FP, false positive, represents the values which are predicted to be true but are false. Next is false negative, represents the values which are predicted to be false but are true. Next is the true positive, represents the values which are predicted to be true and are actually true. Here we have 60 persons without cancer, out of which 50 are correctly predicted and said to be true positive, and the other 10 are false positive. Similarly, for a person who have cancer, here we have 105 people who have cancer. That is this row, which is actually saying those people who have cancer. Out of which we have predicted 100 correctly, that is true positive, and 5 are incorrectly predicted. So here you can see two types of errors. One is the false positive and the other is false negative. False positive says when we predict that something happens and it did not happen, comes under false positive. And false negative is when we predict that something won't happen and it happens, then it comes under false negative. Now how can, and the next question is what is a good confusion matrix? Okay, a good confusion matrix is when you have a high number of true negatives and true positives. So when this number is high, 50 and 100, if you whichever model gives you the sum of these two to be high, that model you can prefer that to be a good ML model for the given data set. Now let us see how a confusion matrix looks for a multi-classes. This is how it looks. Just we'll be having more number of columns and rows. Now let us talk about the evaluation matrix derived from confusion matrix. Precision. Out of all positive classes we have predicted correctly, how many are actually positive? That is what the precision gives us. And recall, out of all positive classes, how much we predicted correctly. It should be as high as possible. Okay, you can see it from the formulas. The formulas are just the definitions which I'm reading, which I'm saying. FN score. Okay, it is difficult to compare two models with low precision and high recall, or vice versa. So to make them comparable, we use the FN score, or also sometimes call it as F score. F score or FN score helps to measure recall and precision at that same time. It uses harmonic mean in place of arithmetic mean by pushing the extreme values more. These are other evaluation methods, RMSE and ROC, but we won't be discussing them in this slide, but I'll provide necessary resources for them. Okay, the final thing is the Amazon SageMaker. Here you can see a brief diagram on machine learning framework. You fetch data, you clean it and pre-process it, then give it into one of the ML model you pick, train them and evaluate the model. Like you get the final result, how the model is performing on the given data set. If it's not performing, you'll repeat again until you repeat this process again and again until you get the best results. You keep on changing the models, you keep on seeing the results, whichever model gives the best data, that is the model you will be considering. And now, what is the role of Amazon Sagemaker here? Amazon Sagemaker is a fully managed service that provides the ability to train, build, and deploy machine learning models quickly. Just within a few clicks on Amazon SageMaker console and through APIs, you can create machine learning models. It is a collection of tools and services. So, but how it is helpful? It abstracts the soft skills, enables data engineers to build and train the machine learning models they want with an intuitive and easy to use set of tools. The heavy lifting needed for developing ML models into ready to roll web service APIs is handled by Amazon SageMaker. Now we will proceed with working of Amazon SageMaker in the next videos or next PPT, whatever we have assigned for you. Thank you.